Part B of this problem, where you use again the result we obtained from the first part. Now we know we gotta create a moment of 86.153 newtons meters, but now with a different equivalent system. Now the equivalent system will be formed by two vertical forces at A and B. Now we're working with couples, so it's fair to say that we need one force at A that goes down and an equivalent, not equivalent, but the same force of the same magnitude that goes up in B, like that. This is actually going to be easier than the last part. Why? Let's enhance this a little bit. We want to create an equivalent system of a couple applied at A, the vertical force like that, and B, with a vertical force like that. Now, to create a couple with two vertical forces, we need perpendicular distance between these action lines, and that perpendicular distance will be this one right here. And we already have it. So if we go back to how to calculate the moment of a couple equals to the perpendicular distance and the forces. Now we already know what's going to be the moment. We already know the perpendicular distance. It's only a matter to solve for F. So solving for F will be equal to mc over perpendicular distance. Force will be equal to 86.153 newtons meters over the perpendicular distance of 125 millimeters. However, that can be expressed as 0.125 meters. Now we can observe that meters and meters, they go away, and we end up only with the newtons. So the force is going to be a total of 692.24 newtons. And this makes sense. Why? For here we got a force that's going down and to the right, and we got kind of a big distance of 300 millimeters. And here we got that small distance. That means the forces we apply must be higher to create that same effect. How do I know the forces are going to be going up in the left and right and down in the right? Sorry. Well, if we kind of analyze this, if we push this section up from here and we push it down from here, the rotation that's being created is going to go like this, clockwise. That means negative, which is actually the one that we obtained from the last part of the problem.